break, you should have the exams and the projects graded. Those are graded by me, so if you have any questions, let me know. Haven't graded the homework assignment 3, I think, right? The last one you submitted before 4, yeah, 4. I didn't get it to the TA before he had to leave, so I'll give it back in a little bit. So did everyone had a good break? I think the exams were, overall were very good. So I was looking sort of for how you were thinking, right? So you may notice that you and your friend may have opposite answers, and I still give them full grades as long as it sort of seems plausible, right? As long as it's not way off. So for example, for the surveillance stuff, right? So depending on where you're, what I want you to think is like there is no simple, easy answer to any of those, right? Some of you said you would choose 4:1:1 because people are going to watch it, it doesn't matter, right? But on the other hand, if you want to do computer analysis, you may have to do 4:4 because computers can actually see or analyze all the colors, right? And same for, some of them seem obvious. You don't want a very small image because then you may not get the detail. So you probably want the 1920 by 1080 or 720 or what have you. But on the other hand, the frames per second, it's not clear what you want to do. 60 seems too big, 1 seems sort of too low. But some of you pointed out that in an airport situation, people don't like fly in and out, or people don't run. So if they run, then that triggers other external events. You don't have to. So if you see somebody running through where you can't capture on the camera, then the security guards can capture them. So normal people walk slowly enough that one frames per second ought to be good enough, kind of thing, right? In the terms of the encoding for real-time system, right? The real-time encoding, right? So what I was looking for was how would you kind of tweak the parameters to make it happen in real time, right? So it'll still be decodable by anything because you're making some decisions, and many of you got sort of the flavor, right? So if you have any questions about a specific answer, talk to me after class, right? Right. So I sent an email before the class, so I was going to actually show some of this stuff because it's sort of it doesn't feel good that you go through this whole class not playing with some of these techniques, rather than having a course project where each one of you will go off and do some things. We like to sort of do it in the class. So we'll start that from next Monday. I'll give you some hint on what we're going to. So we'll look at the media servers, and I'll give a hint of what we will be exactly doing, so you can sort of be prepared, right? So before we go into that, before we talk about media servers and stuff, one of the main things that we kind of haven't touched explicitly, though we kind of so that implicitly is a notion of a quality of service, right? And before I go into details of what quality of service is and all that technical stuff, I'll give you a little demo of what it sort of means, right? This is a very important topic. I'm not going to be able to cover it in one lecture. In fact, I won't be able to cover it within a whole semester or a whole program, right? Because it's very important, and everybody wants to talk about it. Everybody wants to propose new ideas of how to deal with that. And you may realize that none of the research is actually propagated all the way back to normal customers. And I'll try to point out one of the reasons why it's not happening, and which is very fundamental on how these things work, right? So first, I want to go to YouTube again, right? And I just search for my name, and we have all these lectures, right? So I want you to give a sense of what do you think of this, the quality that you're getting for this video. Is this video acceptable to you? What do you think of the way this video is being sent to you? I'm not giving you any parameters of how to evaluate that. I'm just asking you a generic question: how good is this video to you, right? If you look closely enough, you'll see that the thing is sort of. If you look at my hand, right, it won't be as. Do you see it like it's kind of passes and stuff like that, right? But I'm not asking those. I'm just asking in a general sense, is this video acceptable to you, right? Yeah.
Well, I think to learn the information about the class, you don't really need to see exactly where your hand is all the time. I hope the audio is okay. I mean, you haven't been playing the audio.
Yeah, I don't know whether the speaker.
And then, so I think it looks good. It'd be nicer if I could read the PowerPoint better.
Right. So let's go back to this video. Sorry. So now it's not in the high definition, right? Compared to the previous one, is this better or worse? Right? The answer depends on the context of what I'm asking, right? So if you look at the video itself, this will be a lot more smoother than the previous one, right? But if you look at the context of what you mentioned, are you able to see the PowerPoint slides? The previous one might be more useful, right? And if you look at a meta question of, do you actually want to see me on the screen, right? You may not want to see me at all. So this whole thing, regardless of what quality I'm going to give it to you, may not be useful to you, right? So that brings up an interesting problem with all the systems, which is we talked about encoding and all those things, but in some aspect, we want to give this to a user, and we want to make sure that in some sense, you define some sort of a quality to what you're getting, right? And then we can kind of negotiate that. So if you can kind of quantify the quality of the previous high definition version versus this definition in some quantifiable metric, rather than yeah, one looks better than the other one, right? So if I can say the quality of the previous version is the high definition version is like say 9, and this is say 7, right? Then we can kind of figure out how good we are doing, right? So we can figure out with the different compressions, how are we trading off this stuff, and how can we negotiate this stuff? So you as a customer may say, I want my video to be at least a quality of 8, because we have defined this notion of quality, and then we can say, I want a quality of 8, and this one is a quality of 7, and the previous one was a quality of 9, so the previous one was acceptable, and this one is not acceptable, right? And that's the notion of quality of service. Quality of service is basically some notion of how much value you're getting out of this particular system. And if I can quantify that with some sort of a number, then we can sort of negotiate what we have. And as long as it's above that quality, you would be happy. As long as it's below that quality, you may not be happy. And then we can talk about how we can manipulate the system to make sure that your quality is what you want, right? And that's essential, very, very high level idea of what we are trying to achieve, right? And in a practical sense, if all you wanted was quality of 7, then I don't have to kill myself to give you the quality of 9, because all you said was you wanted a 7. So that prevents me from doing it more quality than you asked for, because you may realize that the more quality I want to give to you, there's a cost associated with it, right? The cost may be in terms of the amount of network bandwidth that has to come to you, the amount of CPU that has to be given to you, and all those things. So if I ask you what is the best quality you want, right? Everyone is going to say you want the best quality absolutely possible. You want the high definition in 7.1 stereo and all those, all the stuff you want, right? But if I can quantify and say quality level 1 would be $1, quality level 2 would be some metrics to it, then you could decide, given how much money you want to pay for the stuff, you can figure out what it is, right? So the cost factor may be in terms of dollar in most sense, but in other kind of metrics, right? So quality of service without the cost factor is meaningless, because if you don't have a cost factor, everyone wants the best quality that I can possibly give you. But once you add the cost, then you can kind of figure out how to manipulate this stuff. So then hopefully, if you're a paying customer, then I can give you better quality. So if you belong to the class, I can say this graph will be given to you on a higher quality as opposed to somebody who's not in the class, because you are different users. So I can differentiate this stuff. So I can give you different levels of service, right? So that kind of follows from this notion of quality. So once you define a quality, I can negotiate what you're willing to give you. Then I can also negotiate who are not willing to give you how I can manipulate this stuff. So I want to do the juggling act, right? So that's the high level stuff of how this should happen. And it's not as trivial as it sounds. First of all, you have to have a notion of what is the quality of this object, right? So we have to define what is the quality value we want to give for the stuff. So one higher level, as a human level stuff, is like she pointed out, how much information you're getting out of this video, right? So it may actually mean that you may not think that I was doing a good lecture. So you may think that this video has no value whatsoever, regardless of what the video itself is showing, right? And that goes into the psychology of the object, so which goes into the fact of how much you're getting the information content you're getting out of the stuff, right? So you may not like this lecture regardless of how much quality you have. And that is an important factor, because regardless of how we can say that is unfair or fair, that is something that you as a customer are willing to pay, right? So for example, this may not make much sense for here, but if you're getting a movie or something, you may not like a particular movie because it's too scary or something, and that affects the quality, right? So those come into the category of subjective quality. So here you're asking a user subjectively how much quality they're getting out of the stuff. And subjective quality is considered to be the best quality because that's the one that users really care about. And it's also very hard to figure out because it depends on a subjective matter. So it depends on what you as a human being think about it. So when you look at the JPEG images and all, the quality, the quantization tables are designed using subjective metrics. But it's a very hard topic in general, especially when you go to this different kind of stuff, because you have to do you have to include psychologists to do the study and all those things, right? As a computer scientist, you would like some metrics that can be computed without adding the users. So one of the metrics that we sort of looked at earlier was the PSNR, right? So which can say that there is certain amount of difference between what the signal was sent and what you were watching, and that gives you a metric of quality. Or we can look at other details, like how many of times do you see a more jerky motion rather than a smooth motion, all those things. So we look at these kind of metrics to say what the quality is, right? So now think about how this particular YouTube may be serviced to us, right? So here I have my IE, right, and I have this YouTube video, and here is. Right? So how does this content get from here to my screen? What are the factors which affect the quality of my experience? Let's ignore the subjective component because that's really hard to evaluate from a systematic perspective. In a more objective fashion, what are the things which are involved in this particular setup, right? So you have YouTube.com, which is somewhere, right? Let's say it's in West Coast, right? So you have some sort of a network which takes this stuff all the way to us, right? Which in network sense means that YouTube will talk to its ISP, right? And the ISP will talk to ISPs. It's internet network, so there's a lot of networks going around. So at some point, it talks to an ISP, which talks to the ND campus, right? And then at some point, it will come to this building level. So if this was a wireless, like for example, a laptop, it may involve some wireless component here, right, to reach you, right? And most likely, YouTube is not going to be one single server. They use the notion of a content distribution network, or CDN, where they have replicas all over the country. So when you ask YouTube, they may say, this particular lecture, go to this ISP who happens to be here, who has a cache copy. So the video actually comes from here, right? So they have to choose based on how well they want to service you. So they may give you somebody who's going to make you happy, or they can give you somebody who's good for them, not necessarily for you, right? So you have this kind of networking component involved. You have to figure out within this YouTube or here how they should give you, how they should treat different people differently, right? So for example, they may decide that you are important, so they may treat you differently than somebody else. So the point, and within here you have the operating system, and you have the process scheduling and all those things. And on this machine there are other things going on. So the Microsoft here may decide that the PowerPoint is the most important stuff, not your YouTube. So now you're running as a plugin inside the IE. So the way your system resources are allocated to your Flash player, which happens to be inside IE. So what priority IE gets, what priority your application gets, and all those things affect all things. What it points to is it's an end-to-end concept, not just on your site, right? So if I want to improve the experience I want to get, I have to look at this whole chain. I look at the whole chain of events to figure out how do I make sure that end-to-end, right? If I want a better quality, I would have to work through the system end-to-end to make sure that I will get the good quality from YouTube, the good quality for the packet through these ISPs, right? So it does me no good if YouTube was giving me 1 gigabits per second from here to here, but from this point to this point, I only get 1 megabits per second because somebody didn't tell them that I was important, right? So I want to have the object to be treated, in a good quality fashion all the way till it comes to my browser. If that happens, I'll be happy, right? If that doesn't happen, if one of them fails, then this whole thing won't really work. So I need to have this end-to-end approach, and that makes it incredibly challenging, right? It makes it incredibly challenging because now we have to talk to these different entities to make sure that they all agree with what I want, right? So it's easy for me, since I control this particular PC, to make sure that IE will give me all the resources I need to display this YouTube, but it has to go through this unknown servers to get to me. If any of them don't give the good service, then I suffer, right? So that brings in the question of how do you enforce this? How do you make sure that you get the quality that you want, right? How do you force these guys to give you good quality? What do you think will make them give you good quality? Here's some nameless ISP sitting in the middle, right? It's not a trick question. It's simple. Like, you don't have to worry about, like, it's not a very complicated stuff, right? So how would you force this person to treat you very nicely?
Money.
Yeah, money works, right? Money works in most of these kind of things, right? I mean, you can be nice, you can say please, right? But I don't think ISPs particularly operate on please metric, right? So money works, right? So that's sort of given, right? So all these things start off with there has to be some cost, right? So if there's no cost, then this whole thing goes away, right? If it's free to send any amount of data you want to send from here to here, then I mean, the right answer is send all the information you want because it's all free, but it's not free. So you want to make sure that these things have some value, right? That's one of the things which holds all this stuff up, right? So if I ask you, how much will you be willing to give to get this video in a very good quality? Let's assume the quality is not good enough, right? So if you watch it on a laptop or something, it's not good enough, right? How much will you be willing to pay for this video? Or another question, how much would you be willing to pay for, let's say it's a new movie which came out and you want to watch it on your YouTube, right? So it's a brand new movie, just released on the theaters. They want to give it to you so you can watch it on your screen. How much would you be willing to pay for it? Yeah.
Well, probably less than I get paid the theaters, maybe $4.
So if you're willing to pay $4, right? The challenge is you're willing to pay $4, right? You're willing to pay some entity $4, right, to get this video to you in a good fashion, right? So now you have to decide how much of it you want to give to YouTube, right? Who, let's say, it has to give to some movie theater, right? So somebody in the movie business, the studios have to get some money. YouTube has to get some money, and all these people have to get some money they have to be able to share this money amongst themselves to give you the service you wanted, right? And that's the challenge. I mean, making sure that all these guys can talk to each other and barter this particular traffic, right? Because in real life, what happens is during the middle of the day, things tend to be more expensive than at the night, right? At the middle of the day, there's a lot of traffic. Everybody's doing some stuff. So how do you make sure that this $4 may mean a lot to you, but during the middle of the day, things may be, there are other people who are paying for the service, and how do you make sure that, how does this all get aggregated? So at some level, Notre Dame has to go up and tell somebody, because that's their first ISP, right? So they have to say, I want this good amount of traffic, I'm willing to pay $2. And this ISP may say, oh, at this time of the day, that amount of traffic will cost you more or something. So you have to do this negotiation. You need to figure out what is the best price for coming up with this kind of a system. And as you can imagine, it's not very trivial, right? Because you need to come up with all these parties to negotiate that at this time of the day, this is the best price for this particular network quantity that I want to give to you, right? And it's not a trivial thing, especially when, how many would you really want to pay for this stuff? For, let's say, for this lecture, right? How much would you be willing to pay for it? The answer is going to be 0, right? But it's not 0, right? No, the answer is not 0, right? It's not 0 because you're already paying for it through your tuition, right? So Notre Dame is, I think it's like paying $20,000 a month for ISP service, right? So it gets all bundled up into, you have no control whether you want it or not. So it's all, so I think we have like 200 megabits per second link from between us and Chicago, and so on and so forth, right? So we pay the ISP to get us from here to Chicago. I believe it's $20,000. It keeps changing, right? So we are paying for that service. So to watch this video, it's not free. You're not paying for it, but you're paying for it through your tuition. So we're all paying some amount. I don't know what that amount translates to. If you calculate how much bandwidth we used and divide by what traffic we did, right? So the challenge, but the fact is still true. You don't want to pay anything more than what you already pay. So it's not like you're paying 0, right? You cannot pay $0 for this video, but you don't want to pay anything more for that stuff, right? And the service that you're getting right now is called best effort, which basically says that we had some arrangements and we are basically giving you whatever service we could. And for the most part, the service is okay for you, or if it's not okay, we just live with those kind of consequences. And that's one of the reasons why this whole notion of quality of service, even though there's a lot of work, there's a lot of research and trying to figure out how to do this, make this happen, it's the willingness of people to pay for those stuff, right? There are some class of users who are willing to pay for these services. There are other classes who are not willing to pay for this stuff. And the services which are very popular are the kinds where people don't really pay for it explicitly, right? Nothing is free. I mean, even if you have this at home, you're paying for your DSL, right? So it's never the case that you pay $0 for all the stuff, but you're not willing to pay anything more than what you have to pay. So you just get whatever you want, right? Can you think of a case of an application where you would actually pay for the network to treat you differently, treat you in some other class? There are one class of multimedia applications where people have been known to pay for that kind of a service more than video. Video, I don't think it works yet because people are still quite happy to pay for quality of service from their cable or DSL kind of providers, not exactly going across the network kind of stuff, because you do that all the time, right? So if your cable service gives you a best effort, right? Basically the quality of what you watch depends sort of on your luck, right? Many of us would be unhappy, but on the internet scale, it's kind of different, right? So can you think of an application where you would care about the quality of the network packets that you're getting, that you're willing to pay for it? The application is games, right? Right. So in games, right, depending on what kind of games you're playing, right, the being able to get good quality of service directly affects the kind of game experience that you get, right? So if I can guarantee you that so in games, the main important stuff we'll see further down in the lectures. But essentially, what you're looking for is the round trip delay has to be as low as possible, right? So you want to make sure that when you do something, the other person sees all the stuff. So you want the network to send your packets as quickly as possible, right? You typically don't send lots of data, but you want to make sure the data goes through as quickly as possible. And in that sense, if you directly pay or your game company, your game hosting service pays, regardless of what, right? If you don't get the network, the conditions that you want, you don't get the gaming experience that you like, right? If the network takes too much time for you to play, then you don't get the interactive game feel, so you may tend to go off. So you as a customer and the game company have a motivation to make sure that all these things happen, because otherwise people get bored, because if you don't, if it's a shooting game and if you shoot somebody and they don't die, then you get bored and you kind of move away. So they want to do the stuff, right? But in general, this is a very important topic. We all probably face that. We all probably dealt with this stuff. But I believe one of the reasons why it's not taking off is it's not clear. So the one that Karen pointed out, even if you wanted to pay this $4, it's not clear who you should pay this money to, right? And you have to have the whole holistic approach of how to make this stuff go through. And if some of you follow along the whole network neutrality and all those discussions, they all boil down to some of this nature, right? So how do you make sure that she's willing to pay $4, but how do I pay all these ISPs so that they can get the service you want? Or more importantly, somebody has to come back and tell her, you want good service, but you're willing to pay $4, but actually I can give you good service if you're willing to pay me $5, because that's the negotiated network conditions at this point. And you want that sort of a back and forth involving you, and that we are not close to getting that. Until we get that sort of thing, we are stuck with the notion of a best effort network, which sort of works for the most part, right? And one way to achieve some of this, the notion of quality of service, at least not at the level that we talked about for a particular video and stuff, but in a broader class of case, is the notion of a SLA, right? I mean, if you heard the term SLA, it's a service level agreement, right? So when you have your ISP or something, you sign some sort of agreement saying what sort of service you can get, right? So those are the quality of service parameters that you're signing up for, right? How many of you read the multiple page document that you get when you sign up for DSL or cable or one of those things? I don't think it's possible for any of you to actually read it unless you're a lawyer, right? Because it's not written in a fashion that it's easy for you to understand, right? But you may realize that there's a quality of service thing involved, because when you go to a DSL provider and you get like 6 megabytes per second or something, sort of what I get in my home, for like $35, right? But if you ask for the same service as a company, right, you typically find that 1 megabytes per second would cost you like $400 or something, right? 1 megabytes. So my 6 megabytes per second cost me $1.35, but 1 megabits may cost me, let's say, $400 for the same network, right? So if you haven't gotten one of the commercial lines, you may not realize the difference. But if you look at the commercial rates, they're a lot more expensive. Essentially, the problem is not that you're getting bad bits or something and they're getting good bits or something. Essentially, it all boils down to the service level agreement, right? Your service agreement that you're getting from your DSL provider basically says that you will not get anything more than 6 megabytes per second, right? I mean, of course, they say it in like pages and pages, but essentially they say you will not get more than 6 megabytes per second, right? If you think about it, it's not saying much, right? They're saying that you signed up for 6 megabits per second service, you will not get anything more than that, right? That's the sort of gist of what they're offering you. They're not saying that, so they can give you anything from 0 to 6 megabytes per second. You will never get more than that. I'm not sure anybody here would complain if they give you more than 6 megabytes per second too, because you're only paying for that, right? Whereas these services, they have certain constraints. They have to say, we promise to give you, if you ask for 1 megabits per second, that the bandwidth that you're getting could be anywhere from 400 kbps to 1 megabytes per second. So they can guarantee you the lower bound and the upper bound, right? Upper bound it's not that interesting because that's what you're signed up for. Lower bound is the most important stuff here, right? So they can sort of guarantee you these parameters. The more money you pay, they can guarantee you stuff like, the latency and all the how soon your packet can get through across the continent and all those things. So then what they can do is they can say this particular class of, so I have two class of users. One is this riffraff, the home user. I don't care what happens to their packets. The other ones, they're actually paying for something, right? So now I have to make sure that they're getting certain quality of certain parameters that I negotiate with them. If it goes above these ranges, then there's a penalty. So if you look at the commercial class, they will say, we'll give you this much. You can go up to sustain. So it's a very complicated kind of scenarios. But if they ever fall below those expectations, then there's a penalty associated with it. So they make sure that the network connection that they're setting up will treat these network packets differently. And the notion is differentiated quality of service. So they can differentiate between the different classes, and depending on what class you are, they can actually give you better or worse quality. And those sort of a thing cost money, and those sort of a thing doesn't still work at the level of individual stuff, but they work on a broader scale. They work on the case of all the packets from my business will have higher priority, right? So I have no idea what kind of a contract that Notre Dame signed up with our ISP, right? So our contract may be better than sort of what you get from at your home DSL or something, or maybe the same. But so it depends on the quality that you get. Depends on what they're trying to do, right? And if you happen to be a researcher here, say for example in the campus, and you want to pay for being able to have video chat with or watch this YouTube all the time, so you can probably work with the campus to make sure that, and as long as I pay something, they can give me a good network or something. So all the packets from me will give it different stuff. And all the technical details that we are not going to, don't have time to go into the class, is trying to figure out how do we make sure that these packets are, how these packets are treated differently. So we can't treat all the packets differently. So we need to somehow say these red packets should have higher quality. The green packet should be normal thing. And somebody has to make sure that they sign these things to make sure that these are the right packets and all those things. Think of your U.S. Postal Service kind of thing, right? So you have this different express mail and all those things. And somehow if you pay more and things happen and sort of things happen, right? So so you hope that if you pay for express mail, it goes faster than your first class mail or what have you, and that's what you're trying to achieve, right? So that's the general notion of quality of service. And so this is the notion of quality of service which happens on the network side, right? And we focus more on the network side because that's the one where we don't feel like we have much control, because it's usually controlled by somebody else. You also have to worry about what's the quality of service on your local machine, right? How do you make sure that your local machine can give you all the resources you want to make this video look good or what have you, right? Can you think of a way where how you would manage this on your local machine? How you would differentiate the amount of resources given to give you better quality, right? Can you think of a technique that would get you we looked at it before the break, right? Yeah.
Are you talking about setting up some sort of real-time system?
Yeah, real-time system essentially real-time system falls into that sort of a range, right? So a real-time system, if you imagine that the hard real-time system has higher quality and the other ones have lower quality, so that's a way for you to schedule the system resources. In that case, the CPU, so that you can give to different applications, right? So the quality of service on a particular machine one of the components it uses is the real-time nature, right? So it can give you better CPU, because there's no point in worrying about all the stuff if you can't manage the CPU allocation to the local machine. You may also have to figure out how to do this for memory, right? So this YouTube player would have to get all the memory that it wants. So somehow it has to know the memory allocation has to be prioritized based on whether you are the good application or the riffraff application, right? So it has to do it across the board, right? So it has to make sure that the disk is being treated, in the quality of service fashion, and these applications would get higher quality disk, or the disk is allocated in a certain fashion that the disk appears faster to these applications, right? And you have to do this across the different operating systems. So this may be running Linux and that may be running Windows. So how do you make sure that, again, it's end-to-end stuff, right? So you as a user, so essentially what happens is on some YouTube server, on some disk, this particular video happens to be resident in some block, right? You want to make sure that the YouTube server can make sure that you want higher priority, right? So it can give you higher priority to get stuff out, and then go to give the appropriate amount of CPU, appropriate amount of memory to get it out of the disk. Then you have to worry about the network parameters to get it all the way across, and then the local machine system to make these things, give this to the end user, right? So if you can do so the negotiation involves all these components. And the reason why I'm not going to cover all the stuff is because it's so vast. So people do PhD on just on how to do quality of service on wireless network kind of stuff. We have to consider all possible cases of hardware, all possible cases of software, all possible cases of everything you can think of. But the goal is you have to get a good quality of service, right? And the reason why we talk about this in multimedia rather than other kind of classes is most of the applications don't have this timeliness constraints. So you may not notice what's going on, right? If I'm downloading a FTP file, I sort of expect the FTP to come to me fast, but I'm not going to have any expectations of how fast it has to happen, right? I'll be happy if it's fast. I won't be happy if it's not fast, but not precisely in the same fashion as a video, right? So if I don't get the video every so often, I don't particularly care or whatever, right? And even within the multimedia stuff, many of you noticed from the project that YouTube, right, one of the things that you noticed was, if you look at the number of packets, right, you're watching a video which lasted, let's say this is the time, the video lasted till here, and most of you noticed that you saw some packets here and then nothing here, right? Essentially, what's happening is YouTube, it's no different than a FTP, right? So it's downloading all your video as soon as possible, depending on what kind of network you have. So if you're using an Ethernet, this is probably what you saw. And if you're using a wireless, this is probably what you saw, which means that it takes longer for you to download the stuff, right? So your experience is not directly linked to the network because it's getting stuff as quickly as possible. So it's a lot easier to make you happy with YouTube than other mechanism, right? What is the mechanism that YouTube uses to smooth over the network? All of you pointed this out in the report, by the way. Yeah.
Buffering?
Yeah, it buffers, right? Because there's no real-time constraints. It just buffers everything and plays it out at some instant, right? So that tends to make it a lot easier because essentially you don't really depend on the network. So if the network is fast enough, you're happy, right? The only time you'll be unhappy is if the network becomes too slow and you can't catch up. So your system will stop and say buffering, and you're unhappy, right? Whereas if you're talking about a more like a video chat or something, you will notice this a lot more, right? And we'll try to see what happens in one of these experimental analysis sections. But as you have more of these applications which require interactivity and all those things, you tend to notice these things, right? People don't complain as you watch YouTube or something, but how many of you use voice over IP? One service is Vonage, right? Vonage is one official service, but a lot of other service providers like AT&T and all use voice over IP, right? Voice over IP essentially takes your phone call, makes it into IP datagram, and sends it on the internet, maybe within the company or what have you, to reach the other end, right? So if you use voice over IP services like Vonage and stuff, right? Has any of you used those things? We were supposed to actually go to voice over IP service at Notre Dame. I have no idea why we dropped out, right? This building, I believe, is still in voice over IP, right? So if you go into any of the offices in this building, you'll see a Cisco IP phone, which essentially uses this kind of a technique, right? So in that kind of setup, you would notice the quality of service drop. If I use a phone here, if the network becomes congested, then my call quality will drop. Then I'll kind of complain, right? So there's another application where this thing is sort of noticed a lot more, right? So essentially that's a big, very high level picture of what the issues involved and how you might deal with them, right? And again, all these things are fairly trivial if you have a clean set of principles on how to charge something, right? So if I can figure out how much to charge to another one or the other, then implementation is sort of easier. Then I can say, you are different quality, I should give you better of some resources than the other one, right? And again, I have to make sure that this is end-to-end. It's very important, but you haven't seen too much of that because most of us are not using applications where we are demanding it or willing to pay for it, right? You'll notice it for voice over IP, you'll notice for game thing. Most of us are not watching TV through the systems, except the IPTV systems that AT&T is, for example, deploying in this area. And again, in that particular case, all the network is controlled by AT&T. It's not going on the general internet. So AT&T makes sure that the TV that you watch in IPTV, it's still good enough, right? So if you watch one of those TVs, you won't notice that you're actually watching a different TV because they make sure that all the quality is done. Taking it beyond that to the whole internet is a big challenge. And we'll eventually have to get there as we move more services to the internet, right? I'm still talking. So we'll quickly go through the slides, but essentially it talks about what I just said in the high level in a little bit more details, right? So in terms of the multimedia, there are a number of ways of measuring the quality, right? The quality may be in terms of subjective metrics that I talked about, or more objective stuff like what is the bit rate of video I'm getting, what's the sample size, what's the frames per second, what's the PSNR and all those things. Essentially, you can have certain guarantees. So you as a user may say, I want a service where the audio is at least 8,000 bits per second. And if the network becomes weak enough and you don't get the same quality, then you have violation, you make complaint, right? Yeah, so there's one technology which I think is determinal, which works against this notion of quality of service, right? When you used to have the wired phone, on the wired traditional phone, right? You expected a certain quality, right? You expected a phone where you picked up, the phone calls were made, the calls were not dropped, and the line was not noisy, and all those things, right? I mean, you expected a good quality phone, right? So people used to that concept because they said, I'm paying AT&T or whoever my provider certain amount of money, so I expect a good quality line, right? How many of you are happy with your cell phone, quality of the cell phone calls? Wow, surprisingly, a lot of people are actually happy with the cell phone service, right? But in general, so do you think the quality is as good as your landline phones? Do you pay less than your landline phone, right? So one of the things is the cell phone industry sort of lowered the expectation enough that most people are happy if it drops a phone, you're sort of okay, right? And I never seen anybody actually call your AT&T and say, I got dropped during my call, right? And if the line reception is sort of weak, you're sort of okay, right? Even though you pay more than what you paid for your landline, right? Because we kind of justify ourselves saying like, well, we are able to be mobile right now, so it doesn't matter kind of thing, right? But in some perverse notion, the company sort of got you to accept the lower quality, right? Which is sort of good when they bring in the voice over IP and service because it's still better than your cell phone service, right? So once you lower your expectations to a level where cell phones are good enough, then I can provide voice over IP, which is worse than your regular landline that you used to have, but it's better than a cell phone that you're sort of okay, right? So in the perverse sense, it works out good because once you lower the quality, then it sort of works, right? There's a lot of scientific study to look into people's psychology of what people like, and one of the things is people don't like change. So if it's the same quality, they're happy, right? And these companies use that a lot. If as long as it's uniformly poor, people are happy. If it becomes very good, then you get used to the very goodness, and then you drop off. Then they're not happy, right? So in terms of the quality of service, if you look at it, at every level you have to have a notion of what the quality of service. You as a user care about the end-to-end stuff, but when you build this into a system, you have to worry about it at each individual levels. So you have to worry about the perceptual level, at the application level, at the system level, network level, and so on and so forth. Each one talks about it in a different sense. Each one worries about a different fashion, but the end goal is you want to get the quality you want, right? You have to remember that we are not worried about stuff that cannot be serviced. So if you wanted to watch the video in high definition, and this projector is not high definition, we don't consider that to be something that can be technically solved. You need to buy a better stuff, right? And same, for example, if you're using a wireless, if you're using a cell phone, and you want high definition video, you just can't do it, right? It's just not the question of whether the technology can do it. So all this comes into play where technology can give you better than what you wanted. It's just that because of the way this is being shared, you may not exactly get what you want, right? But you cannot solve the problem of what if you wanted high definition on your cell phone, just wait for a few more years, right? So you don't have to go through the details, but essentially at each level, you worry about different set of parameters. If you're worried about the system level, you worry about CPU and how to allocate, you worry about memory, how to allocate all those things. But somehow they all have to translate back into what you really care about, right? So it's never clear that just because I give you more CPU that you're going to get a better video, right? Your video quality may not depend directly on the amount of CPU. It's not a one-to-one kind of stuff. The amount of memory buffers I give to you may not directly translate into good quality, right? So think of it this way. Your YouTube player may require 1 megabyte of memory for processing a video, right? If you give it 500 kilobyte, it will be unhappy because it's not getting enough memory, right? If you give it 750 kilobyte, it will be unhappy, right? But do you expect the level of quality that you get to change linearly, right? It's not clear, right? At 500 megabyte, it may be completely unusable. 750, it may be 80% there because of the way the encoder works. And if I give you more than what you want, if I give it 10 megabytes, nothing really happens, right? But that's what you have to reconcile. At this level, I'm giving you 80% of the memory that you asked for, but your encoder may just choke and not give you any video at all. So we have to reconcile the fashion of I'm giving you 80% of the memory, but your visual quality may be 0% of what you asked for, right? So how do you make sure that you asked for 80% visual quality, how much does that translate into in terms of CPU, how much does it translate in terms of memory, and so on and so forth, is all the things. So at this level, you worry about certain things, and then you have to figure out how does it map to the global scheme. And then, so you go across the different levels, right? So we're sort of out of time. I'll go through a little bit of the slides in the next lecture before moving on. But see you on Wednesday.